Good evening to everyone. It's not evening yet. Good afternoon to everyone. How are you guys? तबीयत वगैरह सबकी ठीक है? हम्म. सर्दी हो रही है? And protect yourself, from this cold. Hi Swati. Hi Swapna. Hi Pooja. How are you? You can use your chat box na for response. We will wait for 1 or 2 minutes more. So here we are with our lecture number 8 on semiconductor. Okay. This is I think, the second last lecture of this chapter, or maybe the third last. Okay. Till now, so far we have learned about the PN junction diode, and if we connect the PN junction and diode with different kind of electronic circuit and different kind of electronic circuit arrangement, then how it will behave to us. What I trying to say that we have connected this PN junction diode in reverse bias and forward bias, and we have observed that how this PN junction diode will work. Okay. So firstly, make sure that screen is visible to you and I'm audible to you. The screen is clear to you and I'm audible to you. Please respond. Then we will start the lecture. No? So as you guys are not responding, I'm supposing that the screen is visible to you and I'm audible to you. Okay. So without wasting so much time, we will start the lecture now. So semiconductor electronics we are studying. Till now we have studied about that what kind of solid material that we have, and types of solid material based on their conductivity. And based on their conductivity, we will have three type of three type of solid material, that is metal, which is conductor, then semiconductor, and then insulator. All of we have studied about it. Then we have studied about the energy band gap theory. Based on that, we would decide that what material will behave as a semiconductor, conductor, or insulator. So it is all decided by this energy band gap theory. Okay. After that, we have classified the semiconductor. Based on that data, we have classified the semiconductor into two categories: the intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor are the semiconductor which found naturally on Earth surface. Like, there are two types, which is the natural semiconductor and compound semiconductor, or you can say the elemental semiconductor or compound semiconductor, which is silicon, germanium, cadmium sulfide, anthracene, etc. So these are all the semiconductors. Okay, intrinsic type of semiconductor. Then we have studied about the extrinsic semiconductor, because we are not having enough conductivity from that intrinsic semiconductor at room temperature or at normal situations. So we are not able to build any important electronic device from the intrinsic semiconductor. So what do we have to do? We have just adopt these intrinsic semiconductors with some impurities, which are also called as dopants, so that these semiconductor will become more conductive, so that we can use them in the making in the construction of important electronic devices. So these impurities that we have talked about, there are two types of impurities: the pentavalent impurity and the trivalent impurity. Okay. Based on that data, we have decided that two types of extrinsic semiconductor we have: p-type semiconductor and n-type semiconductor. In p-type semiconductor, the majority charge carrier are holes, which are positive unit charge, p4 positive. And in n-type semiconductor, the majority charge carriers are the electrons. Okay. But what is the problem arises then? That individually p and n type of semiconductor are not so much useful to us. So what we have did, we have just combined them and form a junction which is called a p-n junction diode. P-n junction diode. And why it is called diode? So let me show you. I have already told you about it. In p type, this is p and this is n. So p means positive, n means negative. So these two semiconductor, which is p-type semiconductor and n-type semiconductor, will behave as a positive electrode and negative electron. Electrode I am talking about. Okay. So it will, this is a positive electrode, so it will behave as anode, and this will behave as cathode. Okay. These anode and cathode are nothing but, we have in p-n junction, we have p-type and n-type semiconductor attached to it. Okay, attached with each other. So there are two types of electrode we are using. Two means die, and we have steal this ODE. We have stolen this ODE from the electrode, or you can say cathode or anode. We have steal this term ODE and we attach here. So that is why it will become diode. Okay. Okay. So based on this p-n junction diode, we have studied the property of how this p-n junction diode will form. What is the junction formation? What is depletion region? What is the barrier potential? How does we cope up with the barrier potential when we bias and diode, which means the forward biasing and reverse biasing, if we are connecting it to the external circuit, so there are two possibility, which is the diode can be forward bias or it can be reverse bias. Okay. Based on the both biasing condition, we have studied that e- in forward biasing, the less resistance diode will offer, and in reverse biasing, the resistance offered by the diode is too high. So it is acting as a digital switch to us. Got it? After that, we have studied about that special purpose PN junction diode. We have also studied the IV characteristic of PN junction diode. IV characteristics is nothing but the graph drawn between current and voltage. Okay. So based on that data, we have studied about the breakdown voltage. What is a breakdown voltage? What is Zener breakdown? Okay. Now we are here with a special purpose PN junction diode. We have studied two types of special junction PN junction diode. The very first one is very first we have studied the rectifier. Rectifier maybe we have two cases, half wave and full wave. ठीक है. रेक्टिफायर का पर्पस होता है कि ये ऑल्टरनेटिंग करंट को डायरेक्ट करंट में चेंज कर देता है. ठीक है. It converts or it rectify the alternating current into direct current. ठीक है. If it is converting or if it is rectifying only half of the wave of alternating current, so it is termed as half wave rectifier. And if it is converting the full wave or it is rectifying the full wave, it is termed as full wave rectifier. ठीक है. After that, we have studied a very special PN junction diode, which is Zener diode. Zener diode. ठीक है. So till now we have covered with rectifier and Zener diode, and Zener diode acting as a voltage regulator. So these the topics we have covered. Today we are going to cover the remaining three topics, which is the PN junction diode as photodiode, LED light emitting diode, and solar cell. Okay. Okay. So let's just start with it. Rectifier you have understood. So there is not so much of that we need to tell you about the rectifier. But this is for the common understanding. This is the half wave rectifier, setup of half wave rectifier. Okay. This is the full wave rectifier we have, in which two diodes are there. है ना? So we have all studied with it, and the rectifier with filter circuit, in which we add a capacitor to it in parallel to the rectifier. This numerical we have also solved it. Now this has also we have done it. Zener diode, as I've already told you, that in our cricket team there is a player named Bunny. He always hit a century when target is too high, but he always scores very low when the target is very low. So until and unless the pressure is being raised on Bunny, he is not able to hit a big score. Okay? The same goes with Zener diode. Zener diode in normal situation, it will not allow so much of current. Okay? In normal condition, it will be as it is, the normal PN junction diode. But when the value of current is too high in the circuit, then the Zener diode works. सेम एज अ प्लेयर बने। ठीक है, जैसे ही बड़ा स्कोर मिला और उसने धुन दिया सबको, इसी तरह से जैसे ही सर्किट में एक बहुत बड़ा अमाउंट ऑफ करंट आया, वैसे ही जीना डायोड ने भी धुन दिया उस करंट को। सो जीना डायोड इज एक्टिंग एज अ करंट एलिमिनेटर। ठीक है, सो जीना डायोड की वर्किंग कैसे होती है, आई हैव ऑलरेडी टोल्ड यू, बट फॉर टुडे वी एम डिस्कसिंग इट अबाउट। ठीक है, फॉर द रिवीजन पर्पज ऑफ योर ओनली। सो जीना डायोड इज वेरी हाईली डोप। फर्स्ट प्रॉपर्टी तो इसकी यही है, हाईली डोप्ड। इट वर्क्स इन रिवर्स बायसिंग। ओके, नाउ normal p-n junction diode in reverse biasing. Normal p-n junction diode we will have in reverse biasing, which is negative positive, negative positive. In reverse biasing, what will happen? The depletion width increases. Okay. If the depletion width is increasing, so it is very hard for the electron present on n side to get on the p side. But we know that in p side also there are some electrons which are the minority charge carriers. So this electron can easily go through this depletion width. If we increase the reverse biasing voltage, this, if we increase it, so what will happen? This minority charge electron, minor electron, will enter into the depletion width in which immobile charges are present. Immobile charges are and present, and these immobile charges are nothing but the silicon atom. Okay, with aluminium and all. If it is for p type, it is aluminium, and for n type, it is phosphorus. Okay. Now what this minority electron will do? This is silicon bonded with four bonds, two electron pair it will have, है ना? So when this minority electron come with very high kinetic energy, so it will just knock off this electron and itself it is free. So now we have two electrons in the circuit, and this is not happening only for one electron. There are huge number of minority electron, although it is very less in comparison to the concentration of electron in n region, but there is some electrons present in the p region, the minority charge carriers. So each and every minority charge carrier electron will knock off the electron from the bonded site. So this will create a avalanche. Avalanche means whenever from a very high cliff which is made of ice, so if a small piece of ice would break and start its motion downward, so what it will, when it is reaching down, it will gain enough kinetic energy so that when it strikes to the another stone of ice or another ice piece, so it will able to crack it from the surface. Similarly, when that big ice which is cracked out by the smaller one gain the enough momentum, it will strike to another ice piece bigger than it and it will knock off it. This would create, in the end, it would create a ice storm. So this effect of having a having a group of something from nothing, because initially we have one ice piece and finally we have a ice storm. Similarly, initially we have one minor electron, but finally what do we have? We have a bulge amount of electrons. So this effect is called as avalanche effect. Okay. So based on that data, what will happen? A very high current will flow from P to N side, sorry, N to P side, because electron are moving here. So current will flow from this side. And this current is mainly produced by the collision. The collision is happening here. And due to this collision, heat will be generated. And when the number of collision increases, the value of heat will also increase. And this heat will burn out the semiconductor, normal semiconductor. But in case of Zener diode, these P and N junction are heavily doped. So due to this heavy doping, the depletion width is itself very narrow. Okay. If the depletion width is narrow, so we can say that E is equals to, sorry, V is equals to ED. So if the width, which is D, is decreasing, so E has to be increased, because the barrier potential for that particular uh, junction will remain constant. So a very high value of electric field will be there in depletion width. In reverse biasing, if I reverse bias this circuit, the minority electron will jump to depletion width. So the probability of collision is very low, because it has a very high electric field in this region. So if a very high electric field is exist in this region, so whenever the minority electron will enter in the depletion region, it will move with a very high value of acceleration, and it will cross the depletion region without any collision. Or you can say the chances of collision are very less, because the electron is moving very fast. Okay, got it? So there is no chance of heat generation. If there is no heat generation, because there is no collision, no collision. If there is no collision, there is no heat. So a very large value of current will flow, but the potential barrier will not change, or the potential across the depletion width will remain same, and there is no heat effect of it. Okay, but it will also act at some reason, no? For some reason, if the range is like say 1.5 volt for the depletion width, but if you exceed this 1.5 electron or 1.5 volt, then this will behave as a normal diode and it will burn out. Okay, so you will have to keep this as mind. This is in mind. The barrier potential could not be exceed the external voltage. Okay, or the external voltage cannot be exceed from the barrier potential. Okay. So Zener diode is special purpose PN junction diode or the semiconductor diode. तो इसे सी जीनर ने इन्वेंट किया था. Is the here the C zener, and this is represented by this special symbol. This is a Z. ठीक है, and it always used in reverse bias. Very high doping is there, depletion width is low, very extremely high electric field is there, and reverse voltage is very small. Okay. Now if you draw the characteristic of it, when it reaches the VBR, which is the reverse breakdown voltage, the current will immediately shoot up. And if you will see, for this value of current, the value of voltage is this. But if you will see here, the current has changes significantly, but the voltage is not. Voltage is here only. So the very high value change of current, the voltage will remain constant. That is why we are able to use this device, this Zener voltage, Zener diode as a voltage regulator. Because if it's in our circuit, the value of current will increase so much. So what is the problem? We have Zener diode, we install a Zener diode to it, the maximum amount of the current it will take itself and the circuit will remain unaffected. Okay. Now how it will acting as a voltage regulator? So here we have an unregulated voltage supply. This is the Zener diode. Okay. Or let me tell you with an example which I have used in the previous session also. Suppose this is the LED we have. This is a green color LED. Let's say. So this is the LED that we have. The bigger end is the positive one and the lower end is the negative one. Okay. When you want to buy a LED bulb, na, so you will see that one of the limb of it is high in length and one of it is short in length. So the bigger one is the anode and the smaller one is the cathode. Now, if we have a voltage, DC voltage source, okay, and if we connect it to it with the help of a load resistance, let's say this is negative and this is positive. So what will happen if it is a variable source? 1 to 5 volt it will vary, and this LED would require a 3 volt voltage. So if in case 1, if the supply voltage is less than 3, so what will have, you have a dim light in the output, dim light. And if the voltage is greater than 3 volt, so chances of burnout is there, chances of burnout. But if in this circuit you have connected a Zener diode in reverse biasing, here we have the Zener diode, here we have the resistance. So what will have when the supply is less than 3 volt? So, and this Zener diode we have to select as the according to the voltage provided by the LED. So the reverse breakdown voltage of this Zener diode is 3 volt, let's say. So if the voltage is less than 3 volt, according to IV characteristic of it, according to the IV characteristic of it, at 3 volt, the current will shoot up. But before that, the value of current is very low. So the total current it will supply to the LED. Okay. But when the value of external voltage is greater than 3 volt, so for value greater than 3 volt, the current will shoot up. So very high value of current will flow from the Zener diode. So we can say that the most of the current will pass through Zener diode, but the voltage will remain 3 volt. So we can say the voltage across the LED will remain 3 volt because most of the current will be absorbed by this Zener diode. So your LED will work better. Okay, without any chances of burnout, because the heavy current, the maximum amount of current is absorbed by this Zener diode. Now you can say that if the apply voltage is 5 volt, how can be these are connected in parallel? So voltage should be same, because this load resistance that we have provided, it will also have a drop of voltage here. So for Zener diode to be working as 3 volt, this load resistance would absorb a 2 volt voltage. ठीक है, so that the potential difference across the Zener diode will remain 3 volt to satisfy this condition. ठीक है. I hope you are clear with this. So here we have the load. So if the input voltage increases, current through RS and Zener diode also increase, and this increase the voltage drop across RS. इसके अक्रॉस भी वोल्टेज ड्रॉप बढ़ जाएगा, आई हैव टोल्ड यू. एंड जीनर डायोड के अक्रॉस भी वोल्टेज ड्रॉप बढ़ेगा विदाउट एनी चेंज इन जीनर डायोड, बिकॉज जीनर डायोड के अक्रॉस वोल्टेज चेंज होगा ही नहीं, है ना. वी हैव सीन दी IV कैरेक्टरिस्टिक ऑफ इट. सो द RL रिमेन्स अ कांस्टेंट. ठीक है, लोड अक्रॉस द RL बिकॉज RL इज कनेक्टेड अक्रॉस द जीनर डायोड. ठीक है. Now there is a numerical on based on the Zener diode data. So here in the following circuit, what is the current flowing through 1 kilo ohm resistor if the Zener breakdown voltage is 5 volt? Okay. So Zener breakdown voltage is 5 volt. We have to calculate the current flowing through this circuit. Okay. So what we can do, we have the external source which is 10 volt, but we know that across this LED the voltage will remain same, which is across the Zener diode. A Zener diode is operating on 5 volt of electric. So voltage across the Zener diode will always be constant. V is equals to IR. R you are provided with 1 kilo ohm, which is 1 into 10 raised to power 3 ohm. So I will be, because V is equals to IR, voltage across this 1 kilo ohm resistance is 5 volt, which is Zener voltage. I you have to calculate, R you are provided with. So I is equals to 5 upon 10 raised to the power 3, which is 5 into 10 raised to the power minus 3 ampere. Or you can say that 5 milliampere. Okay. Got it? So I hope you are clear with this concept and this question also. Okay. Now we have LED, which is the light emitting diode, or LED you will see. You have mostly heard about the LED bulb, which is you are using, okay, in your household. And recently Diwali has come, okay. In Deepavali, what do we do? We decorate our houses with the help of these LED bulbs, the small LED bulbs. So these are nothing but the light emitting diodes that we are going to study. Okay. So it is a very highly doped PN junction diode, okay, which under forward bias emits a spontaneous radiation, which means if you connect this with the external circuit in forward biasing condition, it will emit light. Okay, that we will see. That light should be in the visible region. Okay, so that you can see it, the red color LED, green color LED, yellow color LED. Okay. So these are the most common LEDs that you have seen. है ना? So this diode is encapsulated. You will see this LED is in a form of a capsule. This LED is in a form of a capsule. So that is why we have used this term encapsulated with a transparent cover so that emitted light can come out. This will be a transparent cover so that emitted light would immediately come out from it, and we will able to see it. Okay. So what will happen? This is the depletion region. This is uh, P semiconductor, P type semiconductor. This is N type semiconductor. Then these are heavily doped. So It is very similar to the working with the silicon diode. The only difference is when the electron hole recombine with each other, okay, they are going into the very high energy state, and from that when they came back, they will emit a certain amount of radiation, which is exactly equals to the radiation of visible light, and that is why we are able to see the color within that. So on electron hole recombination, photons with energy equal to or slightly less than the band gap are emitted. ठीक है, तो जैसे ही इलेक्ट्रॉन होल रिकम्बाइन होंगे, because electron hole recombination means electron is combining with the unfilled energy levels. ठीक है, so in that case it will absorb some kind of photon, but when it reaches to its normal state again, then it will release that photon h nu energy, and that we will see because photon is nothing but the light. When they fill this gap, the photon will release. So as the forward current increases, intensity of light increase, which means the luminosity or the intensity of a LED bulb depends on the forward current that you are providing to it. So this intensity of light increases when the forward current increases. Okay, and reaches a maximum. Further increase in the forward current result in decrease of light intensity, which means there is a certain level that you can increase the current or increase the forward current, and then LED will reach its maximum value. So which means maximum of electrons are going through these holes. Okay, but when you further increase the intensity of light, so electron will move without combination with the hole, so that is why they leave the hole, okay, without recombination, and that is why the intensity would decrease, because if they are not combining, the photon will not release. Now important point you can remember, LED that can emit red, yellow, orange, green, blue light are commercially available. You can go and buy them. We usually do that. Okay. The reverse breakdown voltage of LED are very low. It is less than 5 volt. So care should be taken that high reverse voltage do not appear across them. Suppose that you have buy a LED which has a reverse breakdown voltage as 4.5 volt. Okay, and in your external circuit in which you are putting that LED, the voltage is 10 volt. Okay, so what will happen? This LED will burn out. Okay, so you should take care about that reverse biasing voltage that you are using in your household. Okay, the semiconductor used for fabrication of visual LEDs must at least have a band gap of 1.8 electron volt. And why it is so? This 1.8 electron volt is the energy level of visible light in the spectrum. Okay, which varies from 3 electron volt to 1.5 electron volt. We in energy spectrum we have a certain region from 3800 angstrom to 7000 angstrom. So in this region we are only able to see the colors. Okay, so this is known as the visible region of light, energy spectrum. So energy of visible spectrum is 3 electron volt to 1.8 electron volt. So when we are using, when we are try to make a LED, so LED is a diode. Diode is the PN junction semiconductor. So that material that we are using should be lie with a band gap of 1.8 electron volt to 3 electron volt. Okay. This gallium arsenide phosphorus we would use as the compound semiconductor, and it is used for making LED of different color. You will see here this is 1 minus x and this is x. So if you are taking x as uh, let's say 0.2, then this will become 0.8. Okay. So this is used for the red color LED, which is 1.9 electron volt, which has the low energy. Okay. So high energy will be given to blue light or the purple color light, violet light. है ना? So this compound is used for the red LED, and this 1.4 electron volt, which is less than the visible region. Visible region start from 1.8, but this is 1.4, which is less than the visible region. In this, we have the infrared region, infrared LED, and this infrared LED, we are not able to see the infrared radiation. But these LEDs are very important and very useful. You all must have heard about it, and if you haven't heard about it, you must have used it. Okay? You would have used it. Yeah? This is the LED bulb. In remote control, all of you in your childhood were wondering that if there is a LED bulb type thing is given in the topmost corner of it, topmost section of it, why it is not blinking, why it is not turning on? Because this LED is not the normal LED, it is the infrared LED that we are using, IR radiation. Okay, infrared radiation, which is not visible to us. So it is sending signal to the TV or cable that for which you are using this. In that there is a infrared receiver is there. So it receives the signal and change the channel or change the volume or whatever control that you are using. The virtual alarm system, we will use these LEDs, and the LED TV. The mobile phone which have LED screen will also use the LED. Okay. That is why the LED mobile phone or the LED TV has a high luminosity. Okay. कन्वेंशनल पावर लैंप्स, विच मीन्स द टंगस्टन वाले जो होते हैं ना कन्वेंशनल, उनके ऊपर क्या इसकी एडवांटेज है? इनकेंडेसेंट जो होते हैं, सोडियम लैंप जो होते हैं, सो फॉर दैट पहली डिसएडवांटेज तो इसकी यही है कि इट विल कंज्यूम अ वेरी हाई पावर, दिस हाई पावर यूजेज है इसका. okay. दूसरा, इट विल जनरेट हीट प्रोड्यूस करता है. ठीक है, बट दिस एलईडी इज अ लो ऑपरेशनल वोल्टेज. ठीक है, एंड लेस पावर. इसमें फास्ट एक्शन होता है तुरंत से, एकदम से. ठीक है, वार्म अप, कोई वार्म अप टाइमिंग रिक्वायर्ड नहीं होती. इसकी बैंडविड्थ जो है 100 एंगस्ट्रॉम से 500 एंगस्ट्रॉम, और इन अदर वर्ड्स it is nearly a monochromatic light, which means a single color light you will have. If you are using the white color LED bulb, so only white color is there. This is the meaning of monochromatic radiation. ठीक है, लॉन्ग लाइफ होती है, रगेडनेस भी होती है, इनके साथ वारंटी भी आती है ना, 1 year, 1 year, 2 year, 3 year time. So look how long they are working. Fast switching है, as you put the switch bulb on, as you on the switch, the bulb will definitely on immediately. Now, if you have any kind of doubt in LED, you can ask in the chat box. Now the photodiode or solar cell. Photodiode is nothing but the reverse of LED. What does a LED do? LED is light emitting diode. It emits the light. Okay? It generates the light. But what does a photodiode do? It absorbs the light and then it will conduct the circuit. Okay? So suppose how it is working. There is a PN junction formation we have. If light falls on it, okay, the photon will be absorbed by this PN type material. and there is a flow of electron would take place. So whenever you explore this photodiode with the light, so the circuit that you have connected to it will work because it complete the circuit then. Okay. This is nothing but the you can say it is a sensor, light emitting sensor, sorry, photo sensor you can. Whenever you enter in the room, it will detect you. Whenever the light press on it, it will immediately turn off the light so that you can use it uh, for the power consumption of your household. Okay. Suppose you usually forgot to switch off the light in the morning. Okay. So what you can do, you can put the photodiode to it in the circuit. So whenever the light of sun falls on it, it will immediately turn off the circuit because it work in both the way. Either you put the light on it, it will conduct the electricity, or if you put the light on it, it will immediately cut off the electricity. Okay. So this type, this is the picture of this photo diode. This is the screen on which the radiation will fall. Okay. Or the light will fall. So a photodiode is a special purpose PN junction diode fabricated with a transparent window to allow the light to fall on the diode. So this is very transparent, so the light can easily come through it and get onto it. So reverse biasing में काम करता है. So photodiode is used to vary current. करंट को वेरी करता है by the amount of light that strike it. ज्यादा लाइट होगी तो ज्यादा वेरी करेगा करंट को, कम लाइट होगी तो कम वेरी करेगा करंट. ठीक है. So this is that window on which the light will fall. Okay. The symbol that I forgot to tell you, symbol for LED that we use, this is the diode and we will use it like this. The light is going outward, or you can say like this. Any symbol you can use. Okay. Now what will happen when the photodiode is illuminated, which means the light falls on the surface of this photodiode or the photons with the energy greater than the energy gap. Okay. That is how the p and n type will act as a conductor. So then electron hole pairs are generated due to the absorption of photon. तो जैसे ही photon इस पे strike किया, this will absorb this photon energy. ठीक है. Or if the energy of photon is greater than the band energy, bandwidth, which means the valence band and the conduction band. So if the photon falling on the valence band, the valence band electron will absorb this energy, and if this energy is greater than this gap, Eg, so this will go on into the conduction band and the electricity will conduct. Okay. So that is the purpose of this. So when an external load is connected, current will flow. You can see the photo diode, the characteristic, that is the IV characteristic. So the magnitude of photocurrent is proportional to the incident light intensity. The same you will use for the LED also. Okay. So this is the first one, which means we have I1, I2, I3, I4. So you can say that I4 is maximum. I4 is maximum. So the light intensity for I4 is maximum. And I3 is less than I4 but greater than both the two. So it is this here, then I2, then I1. So intensity will varies according to this. Okay. Now solar cell that we are talking about. So solar cell is also a special p-n junction diode which generates the EMF. Till now what we have studied, that a diode, we have to provide an external voltage and then the diode will work. But in this, the solar cell p-n junction diode, what is happening? It will give us the voltage. the external source. Okay, it absorbs the light, it converts the light energy into electrical energy that we can use it by for charging the battery, for generating for the LED, for our household applications. Okay, and in the satellite also. So a solar cell is basically a PN junction, which is generate EMF, electromotive force, when solar radiation fall on the PN junction. So it works on the same principle as the photodiode, because photodiode is also absorbing some kind of energy. But in photodiode, we have to provide a external voltage also. But in the solar cell, we do not need to provide any external voltage. Although instead of that, it will provide us the external voltage. Okay. So there is no kind of biasing that we need. Now, the junction area of the solar cell is kept very large. These cells are kept very large because what should be the reason? So the maximum amount of light intensity will fall on it. So we have more power. Okay. Construction, if you will see the solar cell, so we have a very thin layer of n type Si semiconductor. We have used Si here. Also you can use the anthracene and selenium also. Okay. So this is the p type semiconductor that we have used. This is n type. You are seeing that the thickness of n is very less than the p type semiconductor. And why it is so? Because we expose the light to n type semiconductor. This is the surface which is in front of the solar radiation. So what will happen when the solar radiation will come? In the solar radiation, photons are coming. So when photons strike this surface, it will travel inside it and losing its energy. So we do not want that photon to be lose all its energy just to traveling inside the n region. We want that photon to be reach or to cross the depletion region. Okay. So that is why the thickness of this n region would be less. So the top and metal fingers are connected to it. You will see these are the metal fingers that are connected to it, and these are the electrode also. They are connecting the current from it, and this will form a front contact. These all are connected to it. This is called the front contact, and the other side, which is the p side, is also connected to a back contact, which is also a metal. So that in the external circuit we have a front contact and back contact, so that we can have the power. Okay. So when the lights falls on it, EMF is generated due to the following three basic process. So first, the photon will fall of a particular frequency, h nu. So this will generate the electron hole pair due to light absorption close to the junction, and that is why we have kept the n side width is very low, so that the electron generated in the n region, it has gained absorbed the photon, so energy of this electron would increase, so it want to cross the depletion region. And if the n region is too large, so this will go to the junction, and then it will not cross it, because most of its energy is used to cross this n region also. So that is why we have kept this n region very thin. So separation of electron and holes due to electric field of the depletion region, electrons are swept out to n side, and holes are swept to p side. Okay. The electron reaching the n side are collected by the front contact, and holes reaching the p side are collected by the back contact. So the electron which is reaching to the n side are collected by these metal fingers, and finally the electron travel through this metal fingers and collected in the front contact, and the holes which are going through this p type, So they are connected by this back contact. This back contact is also a metal strip. Okay. You will see here, when light ray enters, this light rays and the electron will go to this, hole will come to this circuit will complete. And we have connected to the external load. So when an external load is connected to solar cell, a photo current, that is IL, will flow through the current. This photo current will also depends on the intensity of light. IV characteristic is important for it. Okay, for this solar cell, you must remember this. This IV characteristic of solar cell is drawn into the fourth quadrant. Fourth quadrant means negative, negative. Why it is so? So when you provide the voltage, when you supply the voltage, when we have used external voltage, है ना? So it will be taken out as positive value. But uh, when you are getting the voltage, the system is doing the work. Okay? So then it will be taken out as negative. So that is why you keep remember this. The graph, the IV characteristic of solar cell will be drawn in the fourth quadrant, and it will look like this. Okay. So this value of voltage, this amount of current will flow. As you increase the voltage, the amount of current will decreases. This is the open circuit voltage. And this ISC is the short circuit current, the maximum current that you have. Okay. Now in the summary part, Zener diode is a special purpose diode. In reverse bias में ये use करते हैं with a certain voltage. It will also use as the voltage regulator. ठीक है. Light emitting diode, electron excitation by a bias voltage results in the generation of light. ठीक है. In photodiodes, photo excitation is takes place, which means the photons coming to the electrode or coming to the diode will excite the electron hole pair, and it will conduct the electricity. The more the number of photon will come, more is the value of current will there. Okay, so the intensity is directly proportional to the current here. In solar cell converts the photon energy to the electricity with the same concept, the electron hole recombination. Okay, so this is it from my side. If you have any kind of doubt in all the devices that I have discussed, you are free to ask. Otherwise, the lecture is being over. Thank you so much for being attentive. Thank you so much. Okay.